All right, hi everybody. My name's Glen, and I'm from Australia, as basically half the people speaking today, I think. But I'm from Melbourne, like Michael, which is, if you don't know, it's like the most Berlin city of all of the places that aren't Berlin. And it's fun, you should come next year. I'm going to be talking about Interoperable CSS, which is a project I've been involved with for a little while. But I'm going to start with a bit of history, a bit of background. Because if you know your Stoic philosophy, or have seen an episode of Battlestar Galactica, you will know that everything has happened before and everything will happen again. For our purposes, everything happened in September 2008, which was a dark time. 75% of the world was using IE7. We were about here in the global financial crisis, and we all know how that went. But we're about here in Justin Bieber's career, so I think on balance, we were all happier, I think. Thanks. But specifically, I want to talk about JavaScript in 2008, because JavaScript in 2008 looked like this. It got the job done. You can still write JavaScript like this. Many people do. But I want you to look at it critically and think about what it implies about JavaScript at that time. I mean, here we have window.namespace, implying that ahead of this, other stuff will have run. And it will have thrown stuff on namespace. Sorry, on window. And we don't necessarily know what's run in front of us. We don't know what's running after it, so we have to be very careful not to delete anyone else's stuff, but to put our stuff somewhere someone can find it later. Every piece of code that you write, every piece of code, all of your dependencies all execute in this global soup, and you just have to try and carve yourself off a little bit of room to work. Also in September 2008, Google released a comic book announcing that they had built a browser. The comic book was basically to explain to the 75% of people using IE that browsers were a thing and you could choose another one. So why don't you choose Chrome? With that, they brought V8. Now, V8 was a new engine. It was much faster than any of the JavaScript engines around at the time. And it sort of sped up, catalyzed a movement that was already starting around this idea of running JavaScript on the server. Kevin Dangor, back in January 2009, said that for server-side JavaScript to really catch on, it needed some way to include other modules, and for those modules, every module to live in its discrete namespace. Now, there are easy ways to do namespacing, as I showed you with the window.namespace technique, but there's no standard programmatic way to load a module once. He then went on to write in a wiki post saying that all of the attempts so far, all of the server-side JavaScript frameworks were very fragmented. If a script had to do something like access a file, you couldn't use any engine to do that. SpiderMonkey and JavaScript Core, they couldn't load additional modules in the same way. So that anything people were writing was very tied to the interpreter. And they were often forced to create a bunch of APIs that other programmers took for granted. And to me, that sounds a bit like what happens with CSS now. Something that's written for Sass is not necessarily compatible with less. Something that's written for CSS Next doesn't work with either of the others. And each of those add things like variables and loops that every other programmer takes for granted. They're trying to put into this language programming APIs that should just be there. Kris, who was also influential at the time, wrote a blog post and said, "The year has begun with a combination of wondrous events. I've been struggling to promote the idea of a module system in JavaScript for several years, and there had been a sudden explosion of progress, and I feel that way about CSS. I think we can all sort of sense it, that there's something changing about CSS at the moment. We're not sure if we're going to still be doing it the same way in a couple of years." Of course, Ryan Dahl, at this point, Node.js started as a project building on top of V8, and that collective energy gave us CommonJS. The first time it was called CommonJS is July 2009. Now, Node and CommonJS have kind of a complicated history where there were a bunch of different attempts at doing a module system in JavaScript. CommonJS wanted to do more. Node kind of settled on a simple one. And basically, Node won. Whatever Node did was the standard. And Substack calls it CommonJS, which is just like a reduced version of CommonJS. And it's kind of what we all call CommonJS today. But I want you to think about the difference before and after this change. Because now, instead of just assuming that our code ran before our code, that our dependency ran before our dependency, we can be explicit about it. Instead of just putting our code somewhere for other people to find it, we export it. But something in particular is that the words namespace, widgets, and food bar disappeared from this file. They're in the file system. We're able to move that information, move that repetition into the file system. And that'll kind of be important later. I guess it's fair to say Node was a success. NPM came along a little bit later. Things kind of went bananas. I don't know what you're thinking. Like, I'm sure that's great. Like, I'm sure this is all true about JavaScript. But what does it have to do with CSS? I mean, CSS is not JavaScript. Styling code is not server-side code. But again, think critically about what changed. Think about the extension to the language. I mean, this line was valid before. It just didn't do anything. It's valid now, and it has an entire module ecosystem built around it. And all that changed was that there was a convention added to this file. The language didn't change. It was so powerful that it took this language that had a single global context and gave it multiple files, which it couldn't do before. And it had no mechanism for sharing code except by throwing things on a global object. And now it has 175,000 packages on NPM. And what makes that really relevant to us is then in 2011, Browserify came along and said, you can use that mental model, you can use that file system-based approach in the browser. Even though the browser doesn't support it, I will take that directory of files and I'll compile it, and here your project will run in the browser as if it was running on a local file system. Browserify proved that you could change the human interface of the language of JavaScript without needing to change the machine interface. We didn't have to wait for a new version of JavaScript with modules in it. I mean, if we had, we would still be waiting. And if it dropped today, we would have to wait for browsers to support it. But Browserify said, we can separate. We don't have to stay in step with what the browsers are capable of. So of course the question is that possible? Well, in fact, I'll let this guy ask it. Thank you, weird alien conspiracy dude. That's what interoperable CSS is trying to be. All right? And here's what it looks like. It is very small. It is a very small addition to the CSS syntax. There is an import and an export directive. The import references another file and says, hey, some information from that file, I would like to bring it in here, and I'll call it this. It also can export things, saying, hey, if I get included, here's information out. There's a local alias exported token. But the rest of the file is completely global. There's no other changes to CSS. But it's quite different to something like writing modules in JavaScript because it's a compile target. It's not something that we write by hand. It's not good enough to be a human interface. But recently, a lot of our projects have involved a tool, a bundler or a loader called Webpack JSPM or Browserify to be able to build up a collection for the browser of a whole lot of files in the file system. And you can load CSS in that manner. And ICSS is designed to be consumed by one of these. So each file of ICSS is then compiled separately amidst both CSS and JavaScript, and the CSS can get concatenated and inserted into the browser. And we built it because we're trying to build a thing called CSS modules, which I'll be talking about for the rest of today. So it brings me to part 2. Christopher Shadow, who works at Facebook, about a year ago presented these 7 problems as being like the key core problems with CSS. And it was great because nobody had really, I don't think, put the list together and had the scale of developers and the scale of users on a product to really back it up. Of course, he went on to say that if you write your styles in JavaScript, a large class of those, in fact, those 7 just disappear instantly. And I guess it's sort of fair to say that the CSS community wasn't that enthusiastic with it at the time, straight away. Wouldn't necessarily think that it was the best idea. And I was certainly in that camp, but thankfully, a lot of people weren't. And there's a whole host of now projects about doing styling in JavaScript. Now, Facebook has sort of native support for inline styles in the virtual DOM. There's React-style JSX-style and JSS, but I think Radium is probably the most promising at the moment. And they're worth checking out. They're doing something really interesting in a way that basically no one else has done before, and they may be onto something. But I wasn't particularly convinced by them. And in fact, I wrote this in a blog post recently, and it sort of crystallized how we'd all been thinking about it, was that it was more important to keep knowledge about CSS, keep the good parts of CSS within your product and your team, but to solve the real problems, which were being comfortable about making changes and being fast at making changes on a large code base. And I say comfortable before fast, because I think it's a lot more important to be comfortable making changes, particularly in CSS, than it is to go any faster than we can at the moment. And this brings me to the first principle of CSS modules, the thing that drives out basically half of it, is that good design should lead you to good practice. So if we're looking at a new version of CSS that has multiple files and can pass symbols around, what can we do with it? What will it do? What would make CSS easier for humans? And I've been thinking about this a lot, and I think it comes down to this. Every time we've tried to improve CSS, every time we've tried to put a convention on CSS, we've been guiding ourselves to one of these two things. Either focusing on isolation or focusing on reuse. So isolation is when you start with your component and then you write all the styles down, like BEM, right? Everything is nice and separated, so you can add a component really easily, and you can delete a component really easily because there's only one place that the styles are defined. Then, of course, you need to add the ability for those components to share styles, which can lead to large payloads, but generally BEM success has, I think, proven that this is a good approach for a lot of teams. The other side is reuse first, and this is a little bit more like what CSS is actually good at by default, which is you start from the styles and you build up components. So a component will have styles from many parts of your code base. So OOCSS and tachyons like this, and it really captures the visual information in your site with a small file size and good performance, but I believe it's not as successful at the moment because it is difficult for teams, particularly if people have different abilities. If you've got only one person who can touch the CSS on your team, I think this is a symptom of what I call change paralysis, where you're just not confident that the code base is not in a state where anybody can just add something and you think you'll be okay. So CSS modules is trying to unify those two approaches, trying to give you real isolation and responsible reuse. So let's talk about isolation. If you want to target a single element on your page, you can do this. You can nest a lot. If you've used CSS for probably about 4 or 5 minutes, you'll know that that's really bad, right? Because as soon as your DOM changes, as soon as your HTML changes, that doesn't apply. Or suddenly, it might apply to something you weren't trying to style. The alternative, of course, on the other extreme, is you invent a name that has never been seen before to target that exact one thing. And actually, it's better. It's ridiculous, but it's better. And so we put some sanity on it. We say, we invent BEM, basically. We say, OK, every class has to be unique, but here's a nice convention so you can think of a class name really quickly. You know exactly what it's going to be. It implies its context. And yeah, there's a convention that your whole team can learn and apply. But it looks an awful lot like JavaScript in 2008. There's so much repetition there. There's so much information that's just about the fact that the file is global, not about what's happening. And it occurred to me that if you're writing a class for every element in your file, then your class is not a global descriptor. Your class is a local variable. Imagine if, in your JavaScript code, you couldn't use a variable that you'd used anywhere else in that code, or any of your dependencies had used. I don't think we would still be doing JavaScript if that was the case. And so CSS modules tries to fix that problem for CSS. Let's say I'm trying to build this beautiful button. I stole the design for this button from someone who can design. It's 7 lines of CSS, and the only change that you have to make this a CSS module is that. Just drop the noise out of the class name. Just call it normal. It's just the normal button. You've already got component/submitButton.css, right? Something else should be able to tell the machine what this is, but for you, just call it normal. What happens in CSS modules is it compiles to this ICSS. It extracts an export statement, and it rewrites the selector. And this is a really low-level approach that could be used for a whole lot of things to change the way CSS works. So here, the selector becomes normal and then a unique hash. And the export statement says, what you think normal is actually this. And then you can import it into your JavaScript, and you get the mapping from normal to the hash. Once you do that, you can use any method of getting that into the markup. I mean, the only requirement is you have a way to load CSS from your JavaScript, and you have some control over the markup. If you're using Angular, it's really easy. You can even use the bind once syntax, so it has no runtime performance. If you're just using document write, then you could just do that too. Just build up a string, right? But for the rest of my examples, I'll be showing React, because React is already very component-driven. React is already really well supported by things like Webpack and Browserify JSPM, and so it makes sense. It's a really easy conversion to go from React and other styles, other kinds of CSS, to React and CSS modules. And so this is what it looks like to do a button. Now, the class name there is generating. Your JSX file is loading it, injecting it into the DOM, and that HTML is coming out. But it doesn't really matter what that class name is. In fact, in development, I recommend doing something like this, where you have a longer class name which points you towards where that file was. In fact, you can actually put the line number of the definition in the class declaration, and it'll all still work. Note that even though I'm changing this, my component never changes. No matter what the output is, the component has complete isolation to the reality of the CSS. If you want to minify, you can just use the unique component, or, as I like to do, use an emoji. In fact, just this morning, I converted my entire website to use nothing but emoji. I mean, and you can't tell me that, what is that? The selector chicken, firework up, firework down, Chinese lantern, love heart. That's a beautifully meaningful selector that, packs the bytes beautifully. So emoji minifier is a really big feature. But there's another reason that that classes are hard. There's another reason why when you're trying to write styles, sometimes you have to overwrite things and things get messy. And I put a lot of it at the feet of nesting. If you want to name this header 1 inside this header v2 final object, it can be very easy to just nest. But that is a wide-ranging selector. And if you include another component in there that has a h1, suddenly you have to override those styles because of where it's included. And lower there, if you can't think of a good name, then you're leaving this terribly named thing in your global code base, and somebody is going to be very mad at you when they find it. In CSS modules, because the file is local, the pressure is off. If it's a header, call it header. If it's a h1, if that's how you think about it, call it h1 second thing is fine, right? The weird bit at the end, if that is the thing that you're calling it in your team, just call it that. It's a local variable. At least when you see that word, you will see the context from which it comes. Right? You'll see the component, what it is, and then that will trigger, the weird bit at the end of that component, that makes sense. And so I think if you make naming things effortless, if you never have to worry about another global name, you can target everything directly. And if you can target everything directly, you stop leaking styles. And if you stop leaking styles, I think isolation is solved. So let's talk about reuse. Again, I stole this button from someone who can design. Let's say you have two variations of a button. Now, in BEM, you would have the common stuff, then you'd have the normal stuff, then you'd have the error stuff. It works fine. You then include both of those classes on your button. It's fine. It's better than anything that came before it. I like it a lot. But I have a problem with it, which is that when you're looking at your markup, you have to think about how many different classes this thing is being built from. You don't have any separation from your markup and the styling. They are intrinsically connected. And I think this is the other principle of CSS modules design, is that good abstractions are there to save you cognitive load. When you're thinking about one thing, you shouldn't be exposed to the details of another. And this brings me to part 2 of CSS modules, which is called composition. So if we look at our BEM example, we see our 3 classes, button, normal, and error. In CSS modules, you have something called base, it could be called anything. And then normal and error use a keyword called composes, or compose with. What that does is when CSS modules compiles that to ICSS, now the 3 classes, base, normal, and error, they still just get compiled, and their classes and their styles are still presented. But the compose statements disappear. They go up into the export statement. And so now, when you talk about normal, you're actually talking about 2 classes. When you talk about error, you're also talking about 2 classes. Base is just 1. So that export statement, when being imported, now notice that this this component declaration hasn't changed. We're still just using one thing. It generates markup with 2 classes. And breaking I mean, it seems subtle, but like having to worry about how many classes are being applied to this element at that time makes a huge difference to how much context switching you're actually having to do when you're thinking about your component, or when you're thinking about your styles. This gets kind of better with multi-file composition. Because each file in ICSS and CSS modules is completely isolated, you can't reference anything from any other file unless you use a couple of methods, one of which is composes. This is saying that, yes, normal composes base brings all those styles in as well, but it also pulls in 2 classes from colors.css. And this compiles out to, the colors file goes to the top. Again, this is being compiled and then concatenated because it's just CSS after the whole process goes. And the button gets rendered with all 4 classes. You have the blue class, you have the light blue background class, you have the base class, and the normal. And the normal class actually ends up having nothing in it. You've said that this normal thing, it's not a class anymore, it's an element in your application. And you've been able to say that every part of its styles comes from somewhere else. You've just built a piece of, like a novel piece of UI, and not introduced a single line of CSS. I mean, assuming you just strip this out with an optimizer later. And I think that's really powerful. The more times you add UI without adding CSS is good, really good. And this kind of goes on and on and on. Once you start to think about, well, what would you want to compose? What do you want to bring together? How do you want to separate all of the styles in your application? You start to do things like this. You start to say, well, my layout has things like flex vertical centered, margin 1 bottom, padding 1 left, padding 1 right, because it lets you express these 2 objects, an article and a masthead, saying that the article is basically a vertically centered flexbox. The masthead is a 48-point centered bold serif, and needs some padding on the sides and margin on the bottom. Now, this generates markup that's reasonably complicated, lots of classes. But you don't see that. You see this. You just see the article and the masthead, and you can go in and change all the different properties of that thing, and it will change which classes get compiled, but you never worry about that. You worry about one thing at a time, not both. What this is effectively doing is defining an API into your styles. Your CSS module becomes the point at which all of your visual information is collected and passed to your component. And it's that layer in the middle that I believe allows you to solve both isolation and reuse. How am I going for time? Actually, a bit ahead. All right, I'll take a bit longer with my conclusion then. A lot of people, when they start to find out about CSS modules, because I think we did a big blog post about a month ago, And people have been reading it and asking questions. One of the bigger questions is, how does it relate to preprocessors? And I mean, when they say preprocessors, they mean Sass, because 66%, right? That is a bananas number of people to use one tool in our ecosystem. And the truth is, like, we love Sass. I love Sass. There's a lot of love for Sass in the room, because I wouldn't have ever got through the first couple of months of doing CSS had I not had Sass. I couldn't make sense of it without Sass. If you're trying to marry isolation and reuse, then using BEM for isolation, which is what it's really good at, and Sass for reuse is fantastic. I mean, the composers keyword works basically the same as the extends keyword in Sass. It just compiles quite differently and has different performance and other implications. But conceptually, it's the same, right? And that was great. But I do believe that given the way ICSS opens up a new way of doing multi-file CSS, CSS modules can eventually replace the need for Sass. Now, I used kind of inflammatory emoji because there's no emoji for just like genuine respect and admiration for the generation that's gone before. So I went with us wearing sunglasses and them on fire, but like I do actually quite like Sass. So what we're trying to do is take all of the good things from Sass and every other technique, look at what's possible now that a CSS file is actually legitimately local, and then see what we want, see what's good, see what patterns emerge, what anti-patterns we want to get rid of. At the moment, we've added 3 things into the mix in CSS modules. I've told you about 2. The third is a bit smaller, so I don't have time. But that's the game now. We're starting from a new generation of a baseline, and we're looking to see what works. And so you might look at this and not like it. That's fine. You might look at it and love other techniques. You might think we're missing stuff. But I hope that we all agree that these are our goals. These are our goals, and if you come to us with arguments about how we could introduce things into CSS modules that lead to good practice, then that's where we'll go. The other thing is how we can increase or make better abstractions that save cognitive load as you're developing. Then that's the point of this project. I feel like we've made a new capability with things like Webpack JSPM Browserify to make multi-file CSS, and CSS modules is our best shot, our best guess. It isn't just me, by all means. There's a whole lot of people who have contributed discussion, code, ideas. I want to make special mention of Mark and Tobias, who did the original work on the local by default stuff, which really opened this up, really unlocked. I mean, Tobias is a maintainer of Webpack, which makes a big deal. Is a big part of this project. My slides are up there, full of emoji. You can read about it. You can look at the specifications. I definitely welcome feedback. I would love to hear about your use case, and whether it works with our stuff. Yeah, thanks a lot for having me.